Assalamualaikum warahmatullahi wabarakatuh. First of all, let's thanks to Allah who has given us healthy from now on. And let me to introduce myself. My name is Andika Peranginangin. I'm from Pertamina Hulu Energy Nunukan Company. And I was on Pertamina Hulu Energy ONWJ when I was published this poster. And I'm not alone here to publish this paper. The other author here is Raden Budi Andika, Kang Asep Permana, Mas Raden Sebastian, and Mas Darmawan Budi Santoso from Pertamina Hulu Energy ONWJ. Let me to present this poster as the first author here, titled Post-Tech and Pre-Tech Seismic Inversion to Delineate Zones of Basement, Case Study, Zulu Field, Sunda Basin, Northwest Java. Okay, we start from the abstract. So our target in this research is a basement, and it was seen no potential before. But several wells that penetrate the basement indicate hydrocarbon fluids. So Pertamina Hulu Energy conducted extensive GNG studies in the seismic inversion on basement zones. So the point of this research is the comparison between extended elastic impedance inversion, or EEI, and model-based inversion, or MBI, which is EI using the pre-stack data, and for model-based inversion using post-stack data. And one of the well that penetrate the deepest basement is RA1 well. So in this research for the key well is RA1 well. Okay, I will explain the RA1 well first. So based on the well drilling result on the figure 1 here, the basement is divided into 3 intervals. That is weather basement, calcite field fracture basement, and the last is fracture basement. Weather basement has a porosity up to 8%, with the schist composition still has metric porosity, and at this interval there is an indication of hydrocarbon where the total gas increases. With the total gas increases composition C1 until C5, and there is an oil source also. And the second zone is calcite field fracture basement, has the characteristic type and no porosity. And from the image data, this interval appears to be conductive fracture, but based on BSI and Stoney data, the fracture that developed includes closed fracture and has been filled with the calcite. This is also confirmed by the presence of sidewall core, or SWC, at this interval, which shows the fracture that has been filled with calcite. And the last zone is a fracture basement. The fracture basement interval is the main reservoir here, with the reservoir 0.5% until 2% based on the image data. And the open fracture at this interval are represented by the image and the assay data. And it is in the file, it is found that there is an increase in the total gas when it penetrates the fracture. And there is indication of oil source in this zone. There is for the well data, and for the seismic data, because we are using the two method here, we are also using two type the seismic data. The first data is the pre-stack data, and the second is we are using 3D post-stack data. Next, geology regional. Specifically, the ONWJ basin located in the southern part of the Sunda craton, which is comprises active margin rocks due to the plate collation in the Cretaceous, and then in the late Cretaceous, the metamorphism process occurred in the passive margin of Sunda, producing some intrusion in ONWJ. and ultimately as the basement layer data. The northwest corner, where this study took focus, the red box here, in this figure 2, has a proven mature hydrocarbon from Basin, Sunda, and North Seribu Trough based on oil to source rock correlation. This area is located in transfer zone and from the relatively north-south structure and northwest-southeast direction, in which basement layer condition could available due to fracture condition. And this is the red box here, the northwest corner, and the northwest corner is flanked by the Sunda Basin and North Seribu Trough. Okay, we move to method. As what I said before, that we are going to we are using two methods here, model-based inversion and extended elastic inversion method. Model-based inversion is a method that using acoustic impedance as the initial model in bulky form, and model-based inversion workflow, that the basic principle of this method is only by defining the smallest error between the seismic and the model that the other created from using the internal bulky acoustic impedance model. Here you can see the picture here, the figure here. We are calculate the error between the seismic and the model, and with the use seismic data that the want to input it into the distribution of physical properties of acoustic impedance. And in order to reduce the error, the idea is to iteratively updating. So here we are updating the model, until it adequately representing the physical properties or the smallest error between seismic and the model. The second method is extended elastic impedance inversion. The extended elastic impedance inversion was first introduced by Whitcomb et al. And extended elastic impedance is the next step of the elastic impedance inversion using a larger angle or chi angle. So if the elastic impedance angle is only until 30 degrees, the chi angle obtained by the extended elastic impedance reach minus 90 until 90 degrees. And for the formula, the extended elastic impedance here, this is the formula, this method. So in essence, they change the Aki-Richard equation. They change the sine square theta by tangent chi into tangent chi. So they could result this formula and also this formula. And the chi angle have a correlation with the other parameter. We can see this figure that the correlation of this method with different angle turns out to have the same correlation with other properties. We can see in this figure that this parameter with the chi angle 45 with the chi angle of extended elastic impedance 45 have a correlation until 0.9 with this parameter. And the second one, it's a lambda parameter, also have a correlation until 0.99 with the chi angle 19 degree. So how actually this method work? This method work, we can see in this figure the workflow of extended elastic impedance when we are preparing the seismic data. And the seismic data, we are using pre-stack data. So from the gathered data, we are produce the intercept and gradient, and also we are prepared the well that should have the S wave. And then we are generate the log spectrum or a extended elastic impedance spectrum. That is P wave, S wave, and density in the form of a spectrum. And we are prepared the log parameter, and then making a cross correlation between them. So cross correlation between a spectrum and log parameter will produce the chi-angle, and when we have a chi-angle, we are generate the reflectivity extended elastic impedance, and from this input we are perform an inversion. So in this research, we are using a model-based inversion to perform the inversion. To perform this inversion, we are also using the model-based inversion like the first method, because hopefully we are comparing the same process algorithm of inversion with different input. Next, result and discussion. This is the first result of extended elastic impedance is log spectrum or extended elastic spectrum. As we can see, the log spectrum is a form of log P wave, S wave, and also density. And next step is correlation. We make a correlation between log spectrum and log parameter here, and in the figure 7. And we are focusing on log Miro, so we can on this in this figure we can see that log Miro have a correlation with a log parameter and have a chi-angle minus 46 in correlation until 0.99. And if we have a chi-angle, we can produce the reflectivity extended elastic impedance with this formula, A cos chi plus B sin A is intercept, cos chi is the angle, chi-angle minus 46, and B is gradient sin chi-angle minus 46, and we can generate the reflectivity extended elastic impedance. And this is the result of inversion. When we perform an inversion, this reflectivity extended elastic impedance, we perform the inversion, and this is the result. And this is section is inline of the well of RE1 with the gamma ray log here, and same with the this picture the drilling result of RE1, and this is also the gamma ray. And I'm zooming this section into this section. This section have a log green value based on this section. Green to purple color is cancel value that indicate Miro value from low to high. So the purple here is the highest value, and the green here is the lowest value. And the section with a low green value based on drilling result here, we can see that on the drilling result it's basalt, and moderate value it's a weather basement, and the highest with the purple color, is calcite field fracture basement. And it all makes sense because based on drilling result that the calcite field fracture basement has the characteristic of tight, no porosity, and it showed that the highest value of Miro with the purple color, and described on the purple color of the highest value. And the lower than calcite field fracture, it's a weather basement, has a porosity. So the mirror describe the value color is red to blue, and the lowest green to yellow, it should be a basalt sand. And the discontinuous even here, the discontinuous strata, the drilling result, it's a fracture basement, and it's also makes sense because the fracture will make discontinuous even. Okay, the next result, it's a model-based inversion result. So in this model-based inversion result, and also in inline RA1 well, and in this section, it doesn't describe the zone of the basement. We are even in the same parameter, like what I said, it's hard to interpret when we are using model-based inversion result. Maybe the resolution cannot spread the weather basement, calcite field basement fracture, and basement fracture as extended elastic impedance does. So I think in this research, the result of extended elastic impedance inversion is better when interpret the basement than the model-based inversion result. So the conclusion here, inversion using the extended elastic impedance can describe the basement zone. It's a weather basement, calcite field fracture basement, and fracture basement very well. And in contrast to the resolution of model-based inversion, because the result cannot describe the basement zone. So the result that AE or extended elastic impedance could delineate such three zones and more precisely or more accurate than model-based itself. Thank you. I think that's all about my presentation. I would like to say thank you. I would like to thank the PHI ONWJ management to publish this paper, and I also say thank to for their support and discussing during this paper. Thank you. Assalamualaikum warahmatullahi wabarakatuh.